Module 1, Objective 17, identify the importance of nucleotides in the storage of energy and be able to outline the phosphorylation of AMP and ADP. Most of the high-energy compounds found in the cells are derived from nucleotides. Here, the one that you're probably most familiar with is ATP. ATP is a modified nucleotide. If you recall the components of a nucleotide, we have a nitrogenous base. In the case of ATP, it's adenine. We have ribose, a 5-carbon sugar, and then we have a phosphate group. So that is your general nucleotide. By adding 2 more phosphate groups, we actually develop or create ATP, adenosine triphosphate, where tri represents 3. Phosphorylation is the process of adding a phosphate group to another molecule, and this produces a high-energy bond. So basically, AMP, adenosine monophosphate, plus P, I for inorganic phosphate, yields ADP, adenosine diphosphate, and if you add another inorganic phosphate to that, you actually generate ATP. And this is what's happening in the mitochondrion. It's basically phosphorylating molecules of AMP or ADP in order to generate ATP. Notice that between each of these reactions, I put a double arrow, both here and here. And that double arrow is important because it signifies the fact that this reaction is reversible. As the cell utilizes ATP for work, you get a conversion. You get a movement in this direction. ATP yields ADP, adenosine diphosphate, and inorganic phosphate. And if the cell wants to pluck off another phosphate group, it will go further, giving rise to these reactants, or products in this case. And then the mitochondrion will simply reverse and move in this direction for the formation of new ATP molecules. So this is a constant process that occurs in every cell of our body in the production of ATP. So again, that process of adding phosphate groups to another molecule is called phosphorylation, and that's what is occurring here in the production of these high-energy compounds. Please note that we've identified high-energy bonds represented by these yellow squiggly, not yellow, but red rather, red squiggly lines. These are high-energy bonds. I often think of these as like little firecrackers holding these phosphate groups on. And when the cell needs to liberate or use that energy to do work, it simply allows that firecracker to be lit, it bursts, it can capture that energy, force it to do work, and in that case you lose the bond in the phosphate group. You basically get a movement in this direction where you remove a phosphate group. So adenosine monophosphate, it's a nucleotide that contains only 1 phosphate group. Diphosphate contains 2, and triphosphate is the high-energy compound containing 3 phosphate groups. The enzyme that's used to catalyze the conversion of ATP to ADP is adenosine triphosphatase. Remember, when you have ASE at the end of a name, it often represents an enzyme. So adenosine triphosphatase catalyzes the conversion of ATP to ADP. In summary, biochemical building blocks or macromolecules form functional units called cells. And those cells undergo metabolic turnover. They allow for growth of the body, they allow for change, they allow for adaptation. So our metabolic turnover is constantly occurring. as our body metabolically turns over, it recycles and renews all of its chemical components at intervals ranging from minutes to years.